Hi guys, I'm back with my lectures. This is Mr. Joseph, your chemistry teacher. So today we'll be looking at percentage composition by mass and how you can calculate the percentage composition by mass of an element in a compound. A compound is any substance that is formed when two or more elements are chemically combined together. That means in a compound, each of the elements are combined in a definite proportion. That means we can calculate the percentage of each element or each atom that is present in a compound. We can calculate the percentage composition by masses of each of the atom or elements that is present in a compound. So please, I want us to listen attentively and get the best out of today's lecture. So we are looking at percentage composition by mass. So we can use the formula of a compound and the relative atomic mass of that compound to calculate the percentage composition by mass of that element in a compound. Let's take, for example, you are given the compound sodium carbonate, which is Na2CO3. This is sodium carbonate, or otherwise called sodium trioxocarbonate 4, or sodium trioxocarbonate 4. Now, if you look at sodium trioxocarbonate 4, it contains 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. So we can calculate the percentage composition of sodium in sodium carbonate or sodium trioxocarbonate 4. So to calculate the percentage composition by mass of sodium, it will now be equal to 2 times the relative atomic mass of sodium divided by the molar mass of sodium carbonate multiplied by 100 times 100 over 1. So that is that. So I think the formula can be simplified as percentage by mass of carbon by mass is equal to relative atomic mass of that element multiplied by the number of atoms of that element divided by the relative molecular mass or the molar mass. So percentage composition by mass is the atomic mass times the number of moles of particular element in a compound, or the number of atoms of that element in the compound divided by the molar mass of the compound, which is simply written as relative atomic masses of the element multiplied by the number of atoms of that element divided by the molar mass multiplied by 100 over 100 over 1. So it's as simple as ABC. So we're going to look at we're going to take an example so that all you just need to do is to make use of the formula, and it's as simple as ABC. So let's take an example. So example 1. So this is example 1. Now you're asked to calculate the percentage by mass of carbon in ethanol. Ethanol is C2H5OH. That means ethanol contains 2 atoms of carbon, 6 atoms of oxygen, and 6 atoms of hydrogen, and 1 atom of oxygen. So we have to calculate the percentage composition by mass of carbon in ethanol. So all we need to do is is just to apply the formula, percentage composition by mass of carbon will be equal to 2 times the relative atomic mass of carbon divided by the molar mass of ethanol, which is C2H5OH, multiplied by 100 over 1. So since we have 2 atoms of carbon and the relative atomic mass of carbon is 12, so it will be 2 times 12, which is equal to 24. Then we have to calculate the molar mass of ethanol, which is carbon is 12, which is 2 bracket 12, plus we have 6 atoms of hydrogen, 6 bracket 1. Then we have 1 atom of oxygen, which is 16. So to use my calculator, so that means, which is 12 plus 6, 12 times 2, then plus 6, then plus 16 is equal to what? 46. Therefore, 2 times 12, which is 24, divided by the molar mass of ethanol is 46, times what? 100 over 1, which will now be equal to use 24 times 100 is equal to, divided by 46, which is equal to 52.17, which is approximately what? 52.2 what? 0.2% to 1 decimal place. So that is the percentage composition by mass of carbon in what? In ethanol. We can calculate the percentage composition by mass of hydrogen or oxygen. So it's as simple as ABC. All you just need to do is to apply the formula, and it's that simple. So we're going to take, more advanced question, more sophisticated question, more twisted question. It's still the same principle you apply, it's still the same formula you apply. So what you have to do is just to manipulate the formula, just to make normal change of subject of formula, because at times they might ask you to calculate the percentage composition by mass. They might ask you to calculate the relative atomic mass of an element in the compound. They might ask you to calculate the molar mass of what? Of the compound. So let's take the next question. So if you look at this question, let's look at this. This is a little bit different from the first one we solved. Okay, here you are given hemoglobin contains 0.33% by mass of iron. There are 2 iron atoms in 1 molecule of hemoglobin. You are now asked what is the relative molecular mass of what? Hemoglobin. So we have to apply the same principle, the same formula. All we have to do is to make the relative molecular mass the subject of the formula. Then we are on our way to calculate the relative molecular mass of what? Hemoglobin. So using the formula, percentage composition by mass of iron is equal to what? 2 times the relative atomic mass of iron, since we have 2, divided by the molar mass of what? Hemoglobin, times what? 100 over 1. Hemoglobin is a complex molecule. In fact, it's the red pigment in what? In blood. So we have to calculate the relative molecular mass. So we already have what? The percentage composition of iron in hemoglobin, which is 0.33, is equal to 2 times the relative atomic mass of iron is 55.8 over what? Over the molar mass, times what? 100 over 1. So what we are looking for is the relative molecular mass. So we'll cross multiply. So 0.33 times relative molecular mass will be equal to what? 2 times 55.8 times 100. So using my calculator, 0.33 will be equal to 2 times 55.8 times 100 is equal to 11,160. So to calculate the molar mass now, divide both sides by the coefficient of what? The molar mass, which is 0.33. So it will be 0.33 mR is equal to what? 11,160 divided by 0.33, divided by 0.33. So when you cross divide out, molar mass now will be equal to 11,160 divided by 0.33. So you get 33 33,33818, which is equal to what? 34,000 to two significant figure. So that is the relative molecular mass. So as you can see, it's as simple as ABC. It's just for you to apply the formula and make sure you understand the question very, very well. I will encourage you or advise you to solve as many questions as possible. And I'm giving you assignment. I'm giving you a few questions as assignment. Then in our next lecture, I will come back for the correction. So if you've done it, at least if you got the answers right, perfect. But if you have made one mistake or the other, you are going to learn from such mistakes. So please, we are going to learn from your mistakes. So please try as much as possible to solve as many questions as possible and attempt the assignment I will be giving to you today. So thank you very much for listening. Once more, I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me. Please go to my YouTube channel, subscribe, comment, and reach out to me. I'm always there for you. Thank you very much. And please make sure you attempt the questions. So let me give you the questions now. So these are the questions. So I'll be giving you two questions. They're a little bit complex, but not too difficult. These are more advanced questions on what? On percentage composition by mass. So please attempt these questions. They are simple as ABC, just a little bit twisted and a little bit sophisticated and nothing else. So please, I want you to attend these questions and reach out. Please feel free to reach out to me if you have any difficulty attempting the questions. And please try as much as possible to solve the questions. And in our next lecture, the corrections will be done. And if you made a mistake, it will be corrected and you learn from your mistakes. Thank you very much. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me.